chemistry demonstration of a chemical reaction. In this case, one of the chemicals is potassium permanganate, which is a very strong oxidizer. It gives up oxygen very, very readily to anything. And if you put it with glycerin, which is like, it's a hydrocarbon, like, it's not like gasoline, which is also a hydrocarbon. It's like a very thick hydrocarbon. And the permanganate will react with it, I hope. It doesn't always work. I'll tell you a story if I can get it started. And also the temperature makes a difference, and these things are really pretty cold. It needs to be warm to do its thing. And you can come and watch if you want. I'm just going to put a little of this together. Accelerated by adding heat. So we're going to cheat here and add a little heat instead of waiting for this. Something. Oh yes. You might get closer if you can, but I'm going to get back. There you go. This is what happened when he brought it inside and set it on the table in front of the girl. Now let's get back, just in case. Give it a chance to do its thing. Very satisfying. Looks like a volcano. You saw it here. And it will do it by itself. I didn't have to heat it, but it makes it go faster.
I can see how that could have scared the people in the classroom.
Imagine having that in the classroom.
Uh-oh. I don't think it is too. It would be like exhaust smoke from an automobile. It would have carbon dioxide in it. And this permanganate, this is a very common experiment that people will always have seen, but I want to show you it in a little different way. This is baking soda, sodium bicarbonate, and it's a strong base or alkali, fairly strong. And this is vinegar, which is acetic acid, and acetic acid is a mild acid. And when you put the two together, it makes a chemical reaction. It makes a big mess if you're not careful. And the reaction evolves a gas. And the gas is carbon dioxide, which is heavier than air. And you can show that by pouring it into this balance here. I'm not going to pour the liquid, just the gas, and it will upset the balance quite noticeably, even though you can't see anything go in. Let's see if we can make a little more. It's a very common laboratory show to make volcanoes and whatnot. And simple as it is, that's all. Cold. I don't need the lawyers in. I'll just start it. I'll let you heat it up. But when you heat it up, you've got to get it way up here and just go slow. And if it cracks, just keep heating it, and the crack should heal. Let me start here because I wanted to explain. Are we on the air?
Yep. Oh, hold on. Yeah, now we are.
Okay. This is a demonstration of the conductivity of glass. Glass is silicon dioxide, and it is normally a non-conductor. But in this case, what we're going to do is heat it up. And silicon is one of those elements on the stairway. It's a transition element. Sometimes it conducts an electric current, and sometimes it does not. So we have wires here separated by glass, and this is plugged in, but the light is not lighting because the glass is an insulator. If you bridge this gap with something that will conduct a current, the light will come on. So Luca's going to heat this up carefully and slowly. And when it gets really hot and starts to melt, you can push them together a little bit. Don't let the wires touch. But when they get closer together and the glass is really soft, the light should come on.
It's the hottest.
And it gets soft. See if you can push them together and decrease the distance. As long as the wires don't touch, the glass should begin to carry the current. And I'm kind of surprised it isn't. It's so hot. Oh, here we go. So now the glass is conducting the electricity.